All right, one-on-one. Big guy versus a smaller guy. Who's going to come out on top?
Me, obviously. Whatever, I take down guys twice your size all the time.
All right, all right. Well, according to the physics of tackling, we have to look at more than just who's bigger than who. Momentum plays a huge role. Sir Isaac Newton called momentum the quantity of motion, and it's the product of an object's mass and velocity. Here, the running back has more mass, but the defensive back more than makes up for it with his greater velocity. As a result, their combined momentum is in the direction of the defensive player, and the collision moves the runner back. Now, it's also possible that when the mass and velocities of the two are multiplied, that they're exactly equal but in opposite directions. In this case, the momentums completely cancel each other out, and the result is a tie. Now let's keep that bulldog momentum going.
The principle of impulse is a very important one in sport. Basically, it's force times time. And what we mean by that is the amount of force we apply to something over a period of time will affect the impulse that that object has. And that in turn affects its momentum. So if we watch Mr. Bullen hitting the ball just here, we can see that he applies a large force to the ball over an extended period of time. This is why we see athletes follow through with their swing or kick, and that's so they can gain a greater amount of impulse. That gives the ball more momentum, meaning it's going to travel quicker to its destination, hopefully beating its opponent. Momentum is mass times velocity, and it's simply the amount of motion a moving object has. So if something is very heavy and it's travelling quickly, it has a large amount of momentum. Think about a massive, great big articulated lorry, for example, travelling at 100 kilometers an hour. Has an awful lot of momentum and therefore has a lot of trouble stopping. In sport, we see momentum when we hit something or kick something or throw a ball. We have to apply the velocity to it through force, because we can't alter the mass of something during a competition. So the harder we hit something, the greater velocity it will have, and therefore the more momentum it has. And we can even link this to Newton's second law, which is force is mass times acceleration.
And momentum. Let's see what happens when we apply an impulse to an object. For this movie, we will apply an impulse to a baseball. Impulse is equal to the force applied to an object times the time the force is applied to the object. We will apply the force to the baseball with a bat, and the time will be the amount of time in seconds that the bat is in contact with the baseball. The impulse will be equal to the change in momentum of the baseball. The change in momentum is equal to the mass of the baseball times the change in velocity of the baseball. So the force applied to the baseball times the contact time is equal to the mass of the baseball times its change in speed. If you decrease the contact time of the bat on the ball, you will then decrease the change in velocity. This is what makes a bunt work. When applying the bunt, the ball touches the bat for a very short time, creating a small impulse. This leads to a smaller change in velocity for the ball. If you increase the contact time of the bat on the ball, you will then increase the impulse, which increases the change in velocity for the ball. This is why your coach always tells you to follow through. When you hit a home run, you try to swing your bat so it touches the ball as long as possible.